Good morning, ladies and gentlemen. Welcome to the second technical sessions of the Asian SIG Congress Special Interest Group in Vegetable and Ornamentals in Bangkok, Thailand. Although I'm quite new to Apsa, but I would say that this Special Interest Group is one of the most active groups among our technical section programs. And this year, Apsa also arranged study tour in France to see vegetable and ornamentals production in the country, and I'm sure that from the report you will see more details from our chairs and co-chair. So if you are interested to join activities under this special interest group, our chair, Michel, is here to update you in a while about ASRT past activities and our exciting future plan next year. So as a membership programs officer and on behalf of APSA, I'll be here to support our members regarding to the technical session programs and all the study tours. While my full name is a bit too long to remember, you can call me Kuna and just stop saying hi to me anytime. So let me not wasting the time of this session. I just wish for the successful of this session as well as a productive discussion. Thank you very much and have a nice day.
Thank you, Kuna, for this introduction. Ladies and gentlemen, welcome to the Special Interest Group of Vegetables and Ornamentals. So first we're going to start with the agenda. You see that it's quite full on the screen. So we are going to talk about the past activities that our group did over the last 1 year. The study tour just mentioned some information about ASRT2, a report on the APSA R&D Advisory Committee, some updates on the Myanmar seed sector, an update on the APSA World Vegetable Center Breeding Consortium. We're going to have then a brief presentation from ISF to give an update on the vegetable group there. And then we're going to have two presentations. Initially there were to be 3 presentations, but unfortunately Dr. Amitabh Mohanty, who was supposed to make a presentation on the use of CRISPR-Cas9 technology in breeding vegetable varieties, could not make it to this conference. It's a pity because I think CRISPR-Cas is a subject that interests a lot of people, and it would have been good to have his insight on the use of this technology for vegetable seed. Nevertheless, we still have two other speakers. One is about Nutraceuticals in vegetables by Dr. Raiyu Yang from the World Vegetable Center. And we're going to have a presentation on Marigold for the Asia-Pacific region, presented by Mr. Praveen. And then we are going to invite, of course, members for questions and answers, and then close the session. So without further ado, I will, so if you all agree with this agenda, we will go to the minutes of previous meetings. So I'm not going to ask for the vetting of the minutes of the meeting here, because all meetings that we do are minuted, and you can find those minutes on the APSA website. We have had as a group for the last year 5 meetings. This is the 6th one, but every 2 months we are meeting in APSA office with co-chair myself and some other members remotely from China and Japan to basically discuss some topics and prepare the program that we are presenting to you today. So, let me talk to you a little bit about the study tour that took place. So Apsa coordinated a 1-week vegetable seed production and management study tour to France this year during June 2017. 12 company executives representing 10 Apsa members out of 3 countries, namely China, India and Indonesia, participated in the study tour, which besides Paris visited Angers, Toulouse and Avignon. The study tour included the visits and discussion regarding seed production activities, processing, marketing, research, and some regulatory mechanisms in France. The participants visited the facilities of seed production company ASRT, Frasem, the company HM Close, Terrana, and Villemorin. And they learned about advances in seed production, seed quality, and regulatory issues. They also had some discussion with the FNAMS, the Federation of the National Seed Multiplicators in France, the GEVES, the GNIS, INRA, and INOV. So it was quite a complete study tour. It was also partnered, and we have to thank for that, by the UFS and the French Seed Association and GNIS, who sponsored some of these activities. So I will follow suit with the Asian Solanaceous Roundtable, ASRT2. So the group organized the 2nd edition of the Asian Solanaceous Roundtable. It was organized in February 2017 in collaboration with Kasetsart University in Bangkok. The 2 days meeting was participated by about 170 scientists from both the public and the private sector and R&D establishment, and representing about 14 different countries. 24 presentations on the recent advances made in solanaceous crops were presented from 9 different countries, and there were 6 separate technical sessions. The breakout sessions focused on specific themes discussed and identified, like the TOSPO virus, chili anthracnose disease on chili, chili leaf curl virus, and insect resistance. They were to be taken up under the public-private collaboration partnerships. The 2 days of scientific discussions were followed by a field day organized in association with the Tropical Vegetable Research Center of Kasetsart University in Kampeng Sen campus, about 1.5 hour drive north of Bangkok, and the World Vegetable Center. So it was proposed to actually continue these roundtable meetings to eventually come up with an ASRT3 meeting, and eventually open up such a roundtable meeting also on cucurbit crops. Now, some updates on the Apsa R&D Advisory Group. So the major activity that engaged the Apsa R&D Advisory Group this year was, of course, the organization of the ASRT2 meeting. This Apsa platform has become a very useful forum for the R&D executive and the member companies for sharing and gaining new knowledge and information related to this very important group. So they also reviewed the progress and the research outputs of 2 Apsa collaborative projects. One is on the multi-location evaluation of tomato lines carrying different combinations of TY genes for resistance against the begomovirus infection. That collaboration program was done together with the World Vegetable Center in Taiwan. The second project that was reviewed was the development of efficient inoculation protocols for tomato necrotic ring spot virus and capsicum chlorosis virus resistance screening in tomato. That was done with the National Center for Genetic Engineering and Biotechnology, also called Biotech in Thailand, and the National Science and Technology Development Agency of Thailand, NSTDA. Both these projects were completed this year with the final workshop in May and August that took place, with quite some participation of the companies who participated actively in this program. The R&D group was also engaged in reviewing various collaborative projects, such as the ASRT2 related to chili and anthracnose and chili leaf curl virus. And they had also been looking at eventually promoting an okra genome sequencing. This is currently work in progress. Our group research also reached out to the ICAR, the International Council of Agricultural Research in India, to find out if we could initiate some research projects between Apsa member companies and some research institutes in India, a bit in the form that what Apsa is doing with the World Vegetable Center. To that effect, and on the request of ICAR, Apsa wrote a proposal to the organization, and this proposal is currently under discussion. So this is also a work in progress. I hope that we will be able to bring you more information about the development there in the next Apsa meeting. It seems also that there might be some issues related to ownership of research and the use of germplasm and the ownership of this germplasm in India. So these are the things that needs to be ironed out with ICAR at the moment. Another activity that took place is basically the active involvement of Apsa in supporting the seed sector development in Myanmar through the participation in the Vegetable Sector Acceleration Task Force, also called VSAT, and the formation of a Myanmar Seed Association. VSAT is now proposing to merge with the Horticultural Working Group of Myanmar and the Agricultural Network called MAN. This is an arm of the Grow Asia organization, who is quite active in the region. The process of the registration of the Myanmar Seed Association is underway, and it is likely to be completed shortly. A project on integrated seed sector development, and I think this is good information for all of you who are looking eventually at doing business in Myanmar. A project on integrated seed sector development funded by the Netherlands government is being implemented and aimed at improving the seed sector coordination and increasing local availability of quality seed. The 4-year program being implemented in the dry zone is focusing on rice and pulse, green gram, black gram, pigeon pea, chickpea, etc., and oil seeds. An IFC World Bank funded project is presently working on revising Myanmar's seed regulatory framework, focusing on variety registration, seed quality assurance, and seed trade import and export, and associated institutional setup. Myanmar has also started implementing the new plant variety protection law and is likely to become a member of UPOV. So that's also good news for people who want to do seed business there. Finally, another activity that our group undertook was to send a survey that was sent to 152 seed companies who had updated their profile as being involved in vegetable and ornamental seed and be categorized as integrated seed companies in the Apsa database. That means that these companies supposedly have activities in R&D, breeding, production, processing, and sales. This survey basically asked whether there would be an interest in creating a specific working group of integrated seed companies. and ask, among others, the topics that were of highest interest to them to discuss in such a group. So only 26 companies answered this survey, but the most interesting outcome of that survey is that they were all unanimous about creating a small working group on integrated seed companies. That means a smaller forum where the issues could really be discussed in depth. And they also pointed out their willingness to participate actively in such a working group. So based on this result, we pressed on, and we invited those respondents who fitted the criteria of integrated seed companies to a meeting that will take place tomorrow evening. As I told you earlier, that many companies whom we know as integrated seed company had not updated their profile in the Apsa database, so they were not sent the survey at first. So we handpicked a few other companies whom we know are integrated seed companies to invite them to this first meeting. So that's something that we will be continuously updating this larger group about the activity of that small working group. Now, as a last activity that I'd like to report, it's about the Apsa World Vegetable Center Breeding Consortium. It was signed between the two organizations last year and I think implemented this year. So this is in order to have some member companies to benefit from training, information, and germplasm from AVRDC. The highlights of this program with the World Vegetable Center are the possibility to participate in their annual workshop, access to their World Vegetable Replicated Yield trials. They would also receive regularly news and information from the World Vegetable Center, and they could also benefit from free samples from the World Vegetable Center. Sorry. Also, the annual report and some discounts on training. So about 18 companies decided to enroll in this program. And what I hear are quite happy with this. So the tenure of the membership is about for 1 year. It's going to elapse in December this year, but it can be renewed because this consortium that Apsa and the World Vegetable Center signed spans over multiple years. So we invite a company who have not benefited from this program yet that they can enroll starting next year again. And those who were part of the program can of course still renew their participation in such a program. The cost, just for some information, but that information is all available on the Apsa website. The cost for large companies is about $6,900 per year. And for smaller companies, the cost is reduced to $2,900 per year. So I think it's worth investing money in such a program. So this closes basically the list of all the activity that our group did over the past year. So I would like to invite some questions if there are any, and if I'm able to answer some of them. So please, I open the floor for some questions on this eventually. So no questions. So if there is no questions, I think we can go on with the rest of the program. Jack, maybe you can present the next speakers. Thank you.
Good afternoon, ladies and gentlemen. I have the honor to introduce the two speakers that we have invited to this meeting. The first speaker is Dr. Ray Yu Yang. She is the nutritionist and flagship program leader, Healthy Diets, at the World Vegetable Center, Taiwan. She has expertise in coordinating multinational and interdisciplinary projects in technical and operational aspects, such as multi-locational vegetable field trials for evaluation of phytonutrient properties, food and nutrition assessments to identify food gaps, and develop dietary strategies, multi-county school garden and home garden interventions for the improving food and nutrition security, and food-based approach with bitter gourd juice addressing anti-diabetics. She has collaborated with agricultural, socioeconomic, and health scientists on projects, programs emphasizing effective nutrition message delivery systems and nutrition-sensitive and evidence-based agricultural interventions to improve double burdens of malnutrition in lower-income countries. Dr. Yang has, over the past 15 years, characterized more than 150 vegetable species indigenous to tropical Asia and Africa for nutritional, phytochemical, and functional properties, and worked with centers breeders to improve nutritional and functional quality of tomato, eggplant, soybean, vegetable soybean, pumpkin, bitter gourd, crucifer varieties, and several other underutilized crops. I'd like to welcome her to the stage. Dr. Yang? Yes.
Thank you very much for the introduction. It's really my great honor that invited by Apsa and also the special interest groups of the vegetables and ornamentals. So today I'm very happy to share this topic, and particularly I will talk about the vegetables from different lens, from the nutrition and health lens, and share some of our work from the World Vegetable Center. And our Director General also sitting there to support us. Can I have a pointer? So the topics assigned to me is nutraceuticals, vegetables. So overall, I would bring very simple message to this audience. Actually, it's trying to look at the questions, are we fully capturing the nutritional treasures in our diets? So I will, from three major angles, talk about this. First one is diversity and distribution of phytonutrients in the vegetables. And then the health benefits of vegetables and phytonutrients. And then the topics related to improving nutrition and health through plant breeding and plant genetic resources. Then I put a few topics for a discussions. First, I would like to mention about the essential nutrients and phytochemicals, that sometimes the terms might confuse the audience. The phytonutraceuticals basically are isolated or is a mixture of the compounds that from the plant foods, and basically that is used for supplementations. And nutrients, particularly the essential nutrients, those are the ingredients from not only the plant foods, also from the animal source foods, that it's essential for our body's growth and health. And there is another group of the compounds that we call the phytochemicals. And phytochemical basically are the secondary metabolites, or some are the major compounds from the plant food. And those are many diverse compounds and chemicals. However, sometimes we talk about phytochemicals are those health-promoting chemicals. So then we also use the term phytonutrients. So these are similar terms that phytonutrients include essential nutrients and also the health-promoting phytochemicals. And those are the compounds from the plant. So we call it phytonutrients. So in this presentation, I will most focus on the phytonutrients. Okay. So for the nutritional compositions, components in plants, we can divide it into 3 major types: macronutrients that probably consist of 90 to 98% of the dry matter. So those are the carbohydrates, lipids, amino acids, and there are a few thousands of compounds of that. And another group is micronutrients that generally consist of 1 to 10% of the dry weight, so we call it micronutrients. And for example, like minerals, there are 17 essential minerals like iron, zinc, and calcium. And organics common compounds that 13 essential vitamins that we call it vitamin A, B, C, D, and many different categories. And another really diverse kind of a compound is the secondary metabolites are probably more than 200,000 has been in the plants, and then 80,000 being characterized. Some are health promoting, some may have no effects, some may have a poisonous and hazardous to our human health. This is a very complex diagrams. However, I like to show that currently the phytochemicals that are being characterized that related to the health and nutrition and health that we can see from the major food groups. The first one, phenolics. And second one, alkaloids. The third one, nitrogen containing compounds. And the organosulfur compounds. Then phytoesterols and carotenoids. So under that, they have several subgroups of the phytochemicals. So for example, that under the phenolics, there are big groups of the compounds, including the simple phenolic acids and all the flavonoids, different type of flavonoids. So these are the compounds that we are more familiar with, and these are the health benefits has been well characterized in isolated forms. So sometimes we can talk about bioactive compounds, we can group by the functions. For example, those are the compounds that have the characters related to the anti-cancer, or they can influence our blood lipid profiles and antioxidants. And almost most of the compounds have a certain kind of antioxidants and characters, and anti-inflammatory, and also the bone protective effects. So these are just some of the effects that we can group the phytochemicals or phytonutrients into different functions. There are another way that we can classify those phytonutrients actually based on the different types of vegetables. So for example, we are all well known the Solanaceous, particularly tomatoes that are high in lycopene, that is belong to the carotenoids groups. And carotenoids has many different kinds of groups. Some has the pro-vitamin A activities that eventually contribute to our vitamin A requirements. And there are also other kind of compounds that they don't have a vitamin A activities, but they have the health promoting characters. For example, like lycopene. Alpha-coating has a provitamin A, and also lutein that good for the health, the eye health. And broccoli is very common that we know that they have the glucosinolase that also have the fighting cancer compounds. So we can see there are several different compounds can actually characterize by the major groups of the vegetables, fruits and vegetables, and also other plant foods. In sometimes the one type of vegetables that can have many different kinds of functions. So I take this, the beetle gourd as an example. It can consider as a vegetables that is popular in Asia and some parts of the Africa too. And a lot of it, I think, is in America and also in Europe, that if there is Asian populations, and beetle gourd are also popular there. And it's worldwide consumed. However, in other angle, we can also see these vegetables as medicinal plants. They have already shown a lot of functionalities, including the anti-hyperglycemia, anti-lipidemia, and also antioxidants and anti-inflammations. Several functions there. So this is the overview of the phytonutrients. from basically mostly from the vegetables, and also include the fruits and other kind of plant foods like cereals and nuts and legumes. Okay. So here I would like to show you the content range of the phytonutrients in about 250 vegetable species that we categorized at the World Vegetable Center. Why that's important? I would like to show you that what is the background of the phytonutrients that we have. Actually, this is just a part of, we can only characterize so far 150 species, but there are more, there are thousands of species of the plant food that we have not been able to categorize yet. So, so far in our database, we include the common and traditional vegetables, mostly indigenous to Africa, tropical Africa and Asia. So we include the 237 species, and if we count including different types, there are 350 types of vegetables. And the nutritional qualities we selected, we cannot measure everything, but we measure selected essential macro and micronutrients, bioactive compounds, and also anti-nutrients. Because to understand anti-nutrients is also very important, they might reduce the absorption and bioavailability of the nutrients. So these are the indigenous vegetable gardens at a headquarters in Taiwan. And then we have the collections of the traditional vegetables, and we can grow that in our garden or also in the field. And we harvest the edible parts at the best season for the analysis. So these are the laboratory analysis, including macronutrients, micronutrients, ACE, and minerals, calcium, iron, and zinc. Bioactive, including flavonoids, different types of flavonoids, carotenoids, glucosinolates, and antioxidant activity. And also others depends on the species and type of vegetables. Anti-nutrient, particularly we focus on the oxalates and phenolics. We also have an overview review of most of the 7 types of the other anti-nutrients from the vegetables in our database. We also do the LC-MS global profilings. Sometimes we don't know actually those compounds are, so we use the unidentified LC-MS profiles to show that what are the intensity of the phytochemicals in that variety or in that species. To summarize that, I'll just use this table to share with you. We can see that actually very wide the nutritional content range of different kinds of nutrients among the 200 vegetable species. So for example, that for protein, we can have very low protein, almost not detectable, to 11 grams per 100 gram fresh weight. This did not include legumes in the dry weight basis. We can also see, for example, like beta-carotene, we can find from 0 to 22 milligrams per 100 grams on fresh weight. Particularly the, like a total phenolic compound and oxalates. These are very wide range. And where's the concern is the oxalate actually is the major anti-nutrients in the leafy type of vegetables. And that can be very high and reduce the absorption of the mineral, particularly for iron and calcium. So with this figure, sometimes we like to say that, okay, vegetables are rich in vitamins and iron and minerals. So this table can lay us the backgrounds that we would know that the species or the variety that we evaluate or we're breeding for, what are the levels of the nutrient content in the overall that nature gives to us. Here's just an example, the distribution of iron content along this, I think this data is 150 species. And we can see that most of the iron content, the numbers of these frequencies, the numbers of the vegetables. Most of the vegetables were actually clustered in the lower than 2 or 3 milligrams per 100 grams fresh weight. However, we can also find very high iron contents in the, from this pool of the vegetables. And these are the high iron contents vegetables. Most are leafy and dark green. This table I like to show that among all these very wide vegetables, that when we know that tomato and cabbage are principal crops and mostly consumed globally now. Compared to the other kinds of leafy vegetables like moringa, amaranth, and also slippery cabbage, popular in Oceania, and also sweet potato leaves. So you can see that, let's look at the beta-carotene. We can see that for those leafy vegetables are much, much higher compared to the lycopene and cabbages. And for the other nutrients like minerals, iron content and folate content, and also antioxidants. So I would say that in general, vegetables are rich in nutrients content or phytonutrient content. However, they are very, very different, diverse, really different within these very diverse species. What I want to show here is actually you can find a lot of essential nutrient contents in the database. And this is the food composition table you can easily find from the website. This is provided by the FAO Nutrition. They have all the food composition table listed there. It's in food, and they have the composition for Asia, Africa, and also different regions. However, the phytochemical contents are not included in this food composition table yet. Another two major very important food composition table and database are the above is the phytochemical database. You can find phytochemical. Most of it's the quality, it's type of compounds existing in that species, but not many information is available about the content. From the USDA Nutrient Phytochemical Database and Eurofer Basis database, you can find some phytonutrients in these two databases. So there are a lot of information available already that you can find the nutrient content for the plants and the crops that you're working on. Here I would like to show that what's the difference of the World Veg Nutrients database. It's we most focus on not only the common vegetables, we also collect a lot of the traditional and also underutilized that's not commonly included in the international database. So here I compare the species, number of species in this column, compare the World Veg with the USDA database. So the World Veg include 237 species. USDA have the 99 species, though they have many types of vegetable, including cooked, the recipes and type of food. The overlapping are only 57 species. And compared to the other in-food plant species, also the World Veg database that include more species that is difficult to find from other reported papers and also the database. Now I switch to the health benefits. Again, this is a little bit too small. I would like to share with you, this is from the paper recently reported, but the past 10 or 20 decades, actually, there's a lot of study about the health benefits and phytochemicals, phytonutrients, and the vegetables. Overall, I think it's a little bit a certain kind of a bottleneck already, and later I will explain a little bit why. Here is the evidence for the following effects on many different kinds of effects. Like, for example, A categories are anti-carcinogenic, anti-cancer. The B category, antimicrobial activities. C category, antioxidants. D, anti-thrombotic, it's like the blood pressure. And then several, I don't think I want to go through it, but these are different kinds of health effects. Here I want to show you the different type of the phytochemical I show you at the first few slides. Those categories, you can see that those phytochemicals actually can have different kinds of the functionalities. They actually contribute to many different functions. Particularly, we can see the carotenoids, polyphenolics, and also sulfites, that they have all kinds of they contribute all kinds of the functions, the health functions. This is data actually 10 years ago from World Food, World Health, WHO, World Health Organizations. That time they have already did very systematic reviews about the vegetable consumption versus health benefits. So here we can see that what I highlighted here, the fruits and vegetable consumption and physical activity, regular physical activity, can really see it's the convincing. P is probably can enhance, and the angle is either enhance or reduce. So we can see that fruits and vegetables can convincingly or probably reduce those chronic diseases, including type 2 diabetes and cardiovascular diseases and cancers. The most convincing one is actually the regular physical activities compared to the other kind of the intakes of the food intakes. This is more recent that also systematic reviews from the US, and they compare different kinds of the consumptions of the phytochemical or whole food and related to different types of cancers. So we don't go to any detail. We can look at the data, the color. The dark blue is convincingly reduce the risk. Light blue is probably that reduce the risk. The red color is the where convincingly increase the risk. So we can see that I only show one aflatoxin in the plant food. Sometimes aflatoxin is very significant problems. So most of the consumption of the vegetables, fruits and vegetable and plant food, or certain kind of the phytonutrients rich foods have more or less convincingly or probably can contribute to fighting cancers. So from those systematic reviews, really the very evidence-based, they come up very simple evidence-based recommendations, particularly for plant food. So they recommend eat mostly foods of plant origin. And they have the two goals. One is for public health, a population goal. Another one is for individual. So for public health goals, population average consumption of non-starchy vegetables, for example, potato, or belong to starchy vegetables. So not include potato. And the fruits to be at least 600 grams a day. This is really quite ambitious goal for the public health. So another recommendation is relatively unprocessed cereals, grains, and all pods, legumes, and other foods that are a natural source of dietary fibers to contribute to the population average of at least 25 grams of non-starch polysaccharides daily. So the 600 grams is daily. For the personal recommendations, eat at least 5 portion servings a day. I think we all heard about this. This is globally introduced in promotions. At least 400 grams a day for fruits and vegetables. That include a variety of non-starchy vegetables and of fruits every day. And also eat relatively unprocessed cereals, grains, and or pods or legumes with every meals, and limited refined starchy foods. Okay. So sometimes we're talking about nutraceuticals. How about the supplementations? This is a very important compounds. They all contribute to our health. How about we take supplementations? From the evidence they generated, they actually made these recommendations. Aim to meet nutritional needs through diet alone. not particularly with supplementations. So the public health goal maximize the proportion of the population achieving nutritional adequacy without dietary supplements. So if we can have a diverse, fresh fruits and vegetables and other plant foods cooked, and we don't really need the supplementations because those fresh plant foods give us sufficient phytonutrients. So the dietary supplements are not recommended for cancer prevention for the public health goal. However, if individual populations in the areas that we cannot consume enough diverse fruits and vegetables, this doesn't count. I think supplementation still helpful. Now I'm going to switch the topic to improving the nutrition and health through plant breeding and plant genetic resources. I don't think I'm going to talk about breedings here in this group. This will be cause me troubles. But here I would like to mention there are many factors can affect the phytonutrients of vegetables, like genes and also genetic resources, the diversity and also breeding method, production management, climate, environmental factors, growing conditions, post-harvest handling, food processing, and cooking methods. These are all the factors can affect the phytonutrients in the vegetables. In terms of the plant breeding for nutrition and health, so far we heard a lot about the biofortifications. Those are particularly the variety of common, low-cost, staple food crops with higher concentrations of vitamins, mineral, antioxidant fiber, and health oils. So these are also very important that contributes to the overall health and nutrition, particularly for the populations that have a malnutrition, hunger, and micronutrient deficiencies. Another group, particularly to be promoted, is fruits and vegetables. Currently, that we are in the majority, we promote the fruits and vegetables, particularly aiming at enhancing the productivity and also the availability and with affordable prices. So for the past maybe 50, we would say 50 years or 5 decades, that we're aiming at increasing the yields and also particularly the disease-resistant, abiotic and biotic resistance. And there are questions coming out that, for example, increase the yield may compromise the nutritional quality and biodiversity. And there are actually some evidence that have already shown that already. So there are questions that when we're working on breeding to enhance the yield, particularly to address the climate change, do we actually sacrifice some of the good traits, particularly nutritional traits? Those are the hidden traits that it's difficult to measure it because we cannot measure. If we can measure, we have to pay attention already because it's really difficult and also need higher invest to measure it. So also there are questions, increased yield also compromise the nutritional quality and biodiversity. There are several papers being discussed about that, published in different high-impact journals. So I simply list here. So this is actually a question. And I no very solid answer yet. However, here I would like to show you a data that we have from the World Vegetable Center. As I mentioned to you that we collect 250 species. We also work on the traditional vegetables that in Taiwan. Those actually, the vegetables that being taken a lot by our native populations maybe 100 years ago. And then with this, I would like to compare the common vegetables that we consumed in these 10 years in Taiwan. So let's see what is the content range of these 3 vegetables. We can see the green color is the African and Asian traditional vegetables. And these are the content range from the first 5% and 95%, and also the outliers. Okay. So protein, we can, the yellow color is the traditional vegetables in Taiwan that consumes, mostly it's consumed maybe 100 years ago. And the orange colors are those commonly consumed vegetables. I choose top 30s. Taiwan is consume very diverse vegetables. I choose top 30s to make the group average. So we compare the protein. We can see very clear that actually the traditional vegetable in Taiwan, the small group, 60 species, actually comparable to the overall wide diversity of the traditional vegetable in the region, African and Asia. But if we compare to the protein and compare to the commonly consumed vegetables, the content range of protein is lower. Then the similar story we can see from dry matter, much lower because we like high water contents that maybe taste better. We don't like fibrous. That is really makes sense, right? So the lot of high nutrient contents, the density is much lower compared to in general, the traditional vegetables. Sugars, very interesting, because we are emphasizing on the consumer preference and particularly the sweet taste. So we can see that sweet taste didn't lose. It's there. Actually, it's pretty wide range of the common vegetable compared to the wide diversity of the vegetables. The beta-carotene concentration is also very narrow, the common vegetables in the market compared to the wide range of the traditional vegetables. Same story for vitamin C, but not for omega-3 fatty acids. These are, I don't know yet, but this is very interesting. 3 more data to show you. Iron contents representing a mineral, we can see narrow from the common vegetables in the market. Zinc, yes, also narrow. And antioxidants, very narrow compared to the wide diversity of the vegetables. This data shows the biodiversity provides rich phytonutrients that nature gives us. And even that I only characterize 250 species, there are more for evaluations. The nutrient values of the Taiwan AME is the aboriginal groups, the traditional vegetables, equivalent to traditional vegetables from the tropical Asia and Africa. Those are not go through the crop. They're the natural selections only, not from the more accelerated breeding programs yet. The commonly consumed crops in Taiwan, as example, show you as example only, to have less dry matter and less other nutrients such as protein, beta-carotene, vitamin C, minerals, antioxidants, but not for the sugars and omega-3 fatty acids. So the question is, here I just show the Bittergourd, very small part of the diversity in our germplasm. So that information may indicate that, okay, we choose the species, the crops in our markets, actually those are relatively lower content range. Another message that I have not been able to show here is maybe because there are actually a lot of genetic resources very wide for Solanaceous, for crucifer. Actually, the genetic resources, we can find very high nutrient content. However, it's not really reflected in our current diet, in our markets. So we have not really fully realized these nutritional potentials in the treasures. I want to put another type of data to show you the phytonutrient intakes. Okay, so here is based on the consumption data, we have the 24 hours record, the national survey data, and then we collaborate with Academia Sinica. We provide all this plant phytonutrient data to calculate the phytonutrient intakes that include all the plant food, not only the vegetables and foods. So we can see that very high quercetin and lutein. Lutein is type of the carotenoids from green leafy vegetables, because Taiwan eats a lot of green leafy vegetables, and also the quercetin also from green leafy vegetables. We can see from the USA, these are, because this study is collaborate with the US partner and a South Korean partner, we can see that from the USA, the phytonutrient intake very much is screwed into the quercetin and also lycopene. And for Koreans, phytonutrient intakes in general is lower compared to these two countries. I also like to share with you that there are also phytonutrients intake data available. However, they are not used the consumption data that include hundreds of plant food in the current diet. They actually use FAO, food balance sheets data. So it's very much aggregated data. So they can calculate based on 15 major important plant food groups. Then we can see that from the results, we show the major source of the selected phytonutrients. What are the food that contributes to the phytonutrients? So we can see from America and West Europe, Asia, South Africa, and Taiwan that I put it here. Very interestingly, that this data actually for me show that really low diversity of our diets. Because you can see that 50% or even sometimes more than 50% the food source contribute to one phytonutrient. Actually, it's only focused on one or two crops only. So these are really indicates that the narrow diversity in terms of crop diversity and also varietal diversity in our diets. Lycopene's definitely for tomato more than 70%. And interestingly for Taiwan, the highest, you can see that actually more range, 20%, 40%, 11%. There is no one type of superfoods that contributes to a specific phytonutrient. That indicates diversities. Two more data to show here. So you can see that most of the quercetin from the American and Australia diets is from onion. Again, I show this data again. So far that we are working on the phytonutrient intakes, cannot really, not yet work on all kinds of phytonutrients. Only a few that I put on the reds and also the greens box only. So there are many phytonutrients to be incorporated into, to understand what is our diet, what is the gaps in our diet. And if there are gaps, what are the foods that can bring into to fill that phytochemical and dietary gaps? So can we recapture the vegetable diversity and phytonutrients for a healthier diet? So phytonutrients intake vary depending on the availability of crops and diversity. And limited evidence of the health benefits of vegetables may be due to limited high phytonutrient variety and diversity. As what I show you, the data, previous slides, the health benefits of the consumptions of vegetables and foods and other plant food, sometimes convincingly, sometimes not inconsistent. Maybe actually, because the health benefit is evaluated based on our current diet. Maybe our current diets do not have enough diversity and phytonutrient diversity yet. So monitor or piggyback phytonutrients enhancements while breeding for higher high yield and disease resistance traits will be important. And introduce phytonutrient-rich traditional vegetable back into our diets, also very important to fill the gaps. Here are just the suggestions that this is some kind of a topic that we can work together. For example, that I have already shown that our current variety and crops in our food systems. We'll say that now the food system is, we can say, from the more local food system compared to the modernization of food systems. And our food system, during the modernization and urbanization, our food systems sometimes emphasize the efficiency, low costs, convenience. They might maybe reduce certain kind of traditional vegetable consumption or reduce the diversity in order to enhance the efficiency. So maybe we can work on this topic and try to understand how we can incorporate the vegetables, to think about vegetable from a nutrition lens, to understand how we can optimize those vegetables and better integrate into our food system to improve the nutrition and health. So the expected results can be evidence-based recommendations on how the consumption of high phytonutrients content foods can be optimized in the modernization diets and through the more efficient production and marketing the vegetables and fruits. So these are my last slides for discussions. Just want to throw out some questions. Maybe we can consider in setting up some analytical laboratory. We have the laboratory for biotech, for marker assistant breeding, and also final sanitation. So many different kind of laboratory. Maybe we can also think about the laboratories for measure the phytonutrients. Sometimes I know it's difficult. Maybe we can start from the very simple way. We can start to generate information like varietal diversity of major crops, maybe from your varieties in specific regions. That will be a very important information that can provide specs to setting up the priority and what are the varietal diversity we needed to promote for the nutrition and health. And importance, I think it's still very important. We need to understand phytonutrient intakes and gaps to include more type of phytonutrients into such kind of information. Screening protocol is very important that are simple, low cost, and also rapid, that we can evaluate those nutritional qualities. Sometimes we don't need a very fast, a very sophisticated one. We can evaluate just the color or types or shapes. That has association with the nutritional and phytochemical quality already. Another one very important, the message, particularly the evidence-based messages, and also the message delivery systems that can help seed companies or related to promote the nutrition and enhance the public awareness. So maybe these are the topics that we can work together and then to promote the nutrition and health together.
Thank you very much, Dr. Yang, for this very comprehensive presentation. Still show this group here that there is still a lot of work to do to improve our nutrition by breeding better vegetables. I will open the floor now to some questions to Dr. Yang. So if you can pass on the microphone to the person raising the hands, please. Thank you.
Yes. I'm Jesse Gouache from France, and I'm the president of ISF. Just a question related to the study that you presented with the 3 groups of crops and the difference in nutritional value. Since also the way vegetables are grown can have a significant influence in their nutrient composition, it was not clear for me, or at least maybe I missed something, if the comparison was coming from just vegetables being bought in the market and which might have been grown under different conditions, or if it was 3 different genetic sources grown under the same condition. So I would like to know if in your study it was mixing, there was the 2 potential effects, the genetics and the way it was grown, or if you were able to separate them, yes or not. Thank you.
You're talking about GBI effects for the nutritional content of the crops?
For all the components, because you presented the 3 groups, but we don't know if it was only if they were grown under the same conditions, or if it was just buying them on the market, where in that case you would have the combination of both effects.
Yeah. Okay. I think the control factor for this one very important is all the data is generated at the one laboratory. Okay. So that's take away the variations of laboratory analysis variations. The source, the traditional vegetables, what we evaluate most are the seeds that we collect in our gene bank, and then we grow in the South Taiwan climate. So that is under the similar climates. And for the commonly consumed vegetables, that actually we buy the seeds from the major in the markets. And those are the major varieties. And then we grow in our experimental fields so that we also measure the nutrient contents. But only the traditional vegetables in Taiwan, we collected from the field because a lot of the seeds are not available. So we collected basically from the field, from the household, Aboriginal families' household. So that is the only difference. Otherwise, the other factors are quite well controlled. Yeah. Thank you.
Yes, another question in the back.
Ma'am, compared to the vegetables which are harvested and immediately frozen, and to the vegetables which are consumed after 10 days, is there any nutritional difference?
Excuse me, can you present yourself, please?
Yeah,
yes,
hi.
sorry.
This is Hari Prasad from Tilvila Agri Solutions.
Okay, thank you.
Okay, what I want to know is if you compare vegetables which are harvested from the field and immediately frozen and consumed anytime later, compared to the vegetables which are not frozen but consumed after 10 days, is there any nutritional difference?
Okay. Basically, post-harvest handlings, the effect from the nutritional trace and nutritional content, it's not very significant compared to the different genetic sources and also the cooking methods. So your question about if we immediately freeze it or directly bring to the markets, not much difference in terms of micronutrients or macronutrients. But when we frozen it, normally we conduct the bleaching procedure that to capture the nutrients. So frozen actually is a very good way to preserve the nutrient contents. Yeah. And sometimes it is easy. You can see that the nutrient quality is deteriorated compared to when you see the appearance that actually have already showed that is the indications, the loss of the nutrients already. Cooking methods actually is the processing is the factors can significantly reduce the nutrient contents. Different processing and cooking methods.
Thank you for the question. Any other question to Dr. Young?
Thank you for a very good presentation, Dr. Young. I have one more question from my own practice. I'm Simon Group, chairman of the East West Seed Group, and I wonder whether you have found any correlation between plant nutrition and content of valuable nutrients in the crops as harvested, meaning the plant nutrition through the roots intake and the effect on the nutritional value of the final result, the vegetable.
Sorry, your microphone. Yeah.
I did not particularly work on this aspect, but in general, that there are some nutrients can be affected by the soil nutrients, that protein content definitely, and the minerals also. For example, that there are also the soil type that low zinc contents, that all the plant foods will be affected by the zinc content in the soil. So that is one example. But I didn't really work on, but I think it's the soil nutrients will affect the nutrient content in the plants.
Thank you. So, any other question from the floor? If no other question, then I think we can thank Dr. Young for this very good presentation. Thank you very much. We're going to proceed now to the next speaker. And Jack, can you introduce the next speaker, please?
Yes, with pleasure. The next speaker is Mr. Praveen Noojibail. He's a technocrat and entrepreneur with over 25 years of experience in the seed business. He started his independent venture in the year 2000 by launching Sasha Seeds, which was acquired by Seminis subsequently. He is currently the managing director of I&B Seeds Private Limited, a joint venture between Indus Seeds and W. Attlee Burpee Company of the United States. Indus Seeds and SPS, Seed and Plant Science, are two brands which are owned by I&B Seeds. IMB Seed's mission is to breed and commercialize seeds with high resistance to biotic and abiotic stress. The product line of IMB Seeds includes various vegetable seeds with emphasis on Solanaceous crops, especially tomatoes and peppers. But the subject matter in which Mr. Praveen will be addressing is more on the ornamental side, and he will be talking about marigolds.
Good afternoon, and thank you for the opportunity. Thank you for the opportunity, and I think I need to clarify why marigold. I am talking about marigold now, even though my emphasis is on tomatoes and peppers. As you mentioned in your presentation, that my previous company, Sasya, was acquired by Seminis, and I was asked to keep cool for a while. Because of the non-compete, I could not do vegetables, so I thought, let me get into marigolds, and that's how I got into marigolds. And I guess that is the reason why I'm talking now. And I have put here golden opportunity question mark. I wish if somehow Dr. Yang would have mentioned in a speech how to consume marigold flowers, probably the question mark would not be there. It would be probably an exclamation, and then, you know, there's a fantastic opportunity. So an overview of my talk, I'll talk about the types of marigold, the history of the Tagetes genus, uses of marigold, the sales value worldwide, sales value in Europe, sales value in the Americas, sales value in Asia, statistics, and the Asian marigold trends. Regarding statistics, I'd like to and apologize for any mistakes that might happen in the statistics, because it's difficult to gather information. The way the statistics has been gathered is by calling various companies, talking to various friends in different countries, finding out what the marigold market size would be. And the Indian statistics, I would say, is quite accurate, because most of the marigolds in India are imported. And we have government statistics on the quantity and quantum of marigold imported by whom. So the Indian statistics are quite accurate. And the rest of them are fairly accurate, but you know, maybe up for debate. So the main marigold which contributes in value is the African marigold, or called Tagetes erecta. By volume, the French marigold, which is Tagetes petula, covers a larger volume of seed, but the value is lower because it's mainly an OP. And then, of course, there are some Mexican marigolds, which is Tagetes lucida, and then the signet marigolds, Tagetes tenuifolia, so which are not actually that much of a contributing factor for the marigold seed business. If you look at the history of the Tagetes genus, originally the Aztecs, they extensively cultivated marigold. They thought it was a sacred flower, and they used it for their ceremonies. It was also used as a medicinal plant, and they said it would cure hiccups. And also, records show that it has been used for treatment when struck by lightning. I don't know, it's there in the records, but I can't guarantee that. And in the 1500s, the Spaniards who invaded the South and Central America, they took the marigolds from Central America to Spain, and then from there it was moved to France, and from France they used to extensively use it for in their monasteries, in their gardens and those areas. And then when they went to North Africa, they took the seeds of this Tagetes and went to North Africa, and there it got acclimatized in Africa, and the plants became taller after acclimatization, and then the name African marigold came into effect from there. So in the 1920s, what happened was, from Africa and from Europe, the marigold made its way back to America. And W. Atlee Burpee and company was one of the first companies to start breeding marigold in the US, starting in the 1920s. If you look at the uses of marigold, it's predominantly used for gardens and ornamentals. It's also used for oleoresins, and it's also used for garlands and decoration. But if you look at the value, it's predominantly used for gardens. But volume-wise, the oleoresin market is much higher. Now, the total estimated sales value for Marigold seeds, this is the primary sales value. We are talking about from seed company to their distributors, is around $34 million annually. This is worldwide. And out of this $34 million, I think it is estimated that India is the largest value driver for Marigold with $8.5 million a year, followed by Europe at 7.5, then Americas at 5, China at 6, Thailand at 3.5, and rest of the Asia around 3, all in $1 million. Now, Europe, if you look at Europe, it is estimated that French Marigold, about 600 million seeds are sold at a value of about $2.5 million annually. And this is mainly for garden purpose. And if you look at the African Marigold, about 350 million seeds are sold, which is valued around $5 million, or about a ton of Marigold seeds. Going to the Americas, I'm talking about this is mainly USA, North America, where the French Marigold sale is about 375 million seeds, about a ton, and valued at about $1.5 million, as compared to the African Marigold, about 125 million seeds, 350 kilos, and it is valued at around $1.75 million. And the rest of the Americas, there is South America and the Canada, and maybe about $1.75 million. And the main use in Europe and US is only for ornamental in the gardens. Now, if you come to sales values of Asia, the oleoresin market in Asia, which is predominantly in China and in India, it's estimated that about 10 to 12 tons of Marigold seeds are sold for the oleoresin market. And in the oleoresin market, the value is slightly cheaper, and price per kilo is cheaper, and it's estimated about $2.5 million worth of Marigold seeds are sold for the oleoresin market. And the ornamental market, which is mainly the garden market, which you use for beautifying, it's around 8.5 tons in Asia, and the value is approximately $10 million. And then the next topic is predominantly, it's a specialty of Thailand and India, only in these two countries where Marigold is used for cut flowers or garland purpose. And it's estimated that the cut flower market is around 3.5 tons or $8.5 million, because the cut flower, it is sold at a much higher value than oleoresin and ornamental purpose. So China, this is the estimated figure. This is not China's export. China exports a lot of Marigold seeds. But this is the domestic consumption in China, and the values are, maybe correct or maybe up for arbitration. But if you look at erecta, Tagetes erecta, and China consumes mainly for garden purpose, for ornamental purpose. And apart from the oleoresin purpose, the erecta is consumed mainly for garden purpose. About a ton of it is sold, valued at around $2 million a year. And then 5 tons of patula for garden purpose, valued at around $2.5 million. And about 5 tons of Marigold seed is consumed for oleoresin purpose, valued at about $1.5 million. And a total of 11 tons of consumption of Marigold seed in China, valued at around $6 million. China being a major supplier of Marigold, I think it is estimated that their own sales in China is at a much lower value than the value which they sell to others. Then if you look at Thailand statistics, Thailand mainly grows Marigold for cut flowers, and the ornamental purpose is much smaller than the cut flowers. It's estimated that for cut flowers, about 500 kilos of Marigold is sold in Thailand every year, valued at around $2.75 million. But this year, due to the king's death and ceremonies associated with king's death, this year they have sold over a ton of Marigold seeds. And it is expected that this ton is probably going to spill over to next year also, because there's going to be a new king and new celebrations are going to take place, and you know, they are expecting a demand. But the problem is going to happen when the ton of marigold seed, which is sold in 1 year, next year they are going to produce this ton, and there's going to be a lot of seed with little consumption. And for ornamental purpose, maybe about 100 kilos is sold and valued at around $600,000. Southeast Asia figures, I could not get a breakup of you know, the patula and erecta. What is the breakup of that? But when I talked around, they said, you know, approximately 400 kilos or $1.6 million in Vietnam, Indonesia, and Philippines. And Japan, Korea, about 200 kilos of marigold valued about $1 million. And then that makes the total Southeast Asia, other than, you know, these countries, about 600 kilos or $2.6 million US. Now, these are the Indian import statistics. These figures are absolutely right, because this is from the statistics of the government department where marigold seed has been imported, how much has been imported by whom, and at what value. Here for India, we have the financial year. I should have actually corrected this. Our financial year goes from April to March. So my statistics, when I say year, it is from April to March. So I have given statistics from April to March for year 14-15, 15-16, 16-17, and first 5 months of this financial year, April to August. If you look at 14-15, a total of 3.3 tons of marigold seed was imported into India, out of which about 1.2 tons was for garlands, and about 2 tons was for oleoresin extraction. And in the year 15-16, 7.4 tons of marigold seed was imported into India, out of which 1.38 tons was for garlands and cut flowers, and the remaining 6 tons was for oleoresin extraction. And in 16-17, about 2.4 tons of marigold seed was imported into India for garlands, and 3.3 tons was for oleoresin extraction. And this financial year, surprisingly, there's only 901 kilos which has been imported till August. That is April to August, 5 months. And nothing of xanthophyll has been imported this year, as per the statistics. The reason why this year probably it's only 900 kilos is because last year, that is 16-17, about 2.4 tons was imported, and it is likely that it is a spillover from last year to this year, because I think the best estimate of garden cut flower market in India is about 1,500 kilos to 1,750 kilos maximum. Now, if you look at the values of these imports, 14-15, the total value of imports was $5.21 million. 15-16, the value of import was $7.5 million. 16-17, it was $8.7 million. And this year, $1.7 million so far in the last five months. And then if you look at the value, if you see that majority of the value for marigold seeds is coming from the garlands and not from the oleoresin. Now, who are the biggies in India? If you look at the biggies in India, by quantity, the largest importer is A.V. Thomas, Natural Products Limited. A.V. Thomas in the last 3 years has imported about 4.5 tons of marigold at $1.65 million value. And if you look for the garland, the biggest importer is East West. East West in the last 3 years has imported about 1.65 tons of marigold at over $5 million in value. So these are the two biggies for marigold in India. Now, what are the trends? The number of suppliers are increasing. People think it's a golden opportunity. That's why I put a question mark. Earlier on, when I started the business in 2010-12, there were hardly 3 to 4 people supplying breeding marigolds in Asia. But today, the number has just quadrupled, minimum. There are at least 10 to 15 people supplying marigolds. And the other trends is, what happened is initially India was growing a lot of chrysanthemum for cut flowers, and then chrysanthemum is a long duration crop. It got affected by disease. That is the reason why people started shifting to marigold. And when they shifted to marigold, they found that it was a very easy crop to grow, very short duration, not much of crop production required, easy money. So that's how the marigold started improving. Then the main sales value is coming from cut flowers, like I told you. The volume of Marigold sold in India is now stabilizing. It's already stabilized. The number of companies offering Marigold has just mushroomed. Not just the people selling Marigold, but the people supplying Marigold into India. And the margins are reducing and the selling price is on the decline. So if you look at the price trends of Marigold in India, if you look at the year 14-15, the average import price was $3,070 for the garland marigolds, and for oleoresin marigold it was $295 per kilo. And if you look at 15-16, the price went up a little bit, $3,500 per kilo import price for garlands, and for oleoresin it was around $300 per kilo. And 16-17, look at the price drop. It dropped to $2,545 per kilo. And the oleoresin market surprisingly increased to over $430 a kilo. And this year, 17-18, the average price of every kilo imported is $2,329. Now, what are the trends? Margins are on the decline. In 2010 and 12, we used to import marigold at $4,500 a kilo average. This is 2010-12. Today, we are selling at less than $4,000 a kilo. So what we used to import 5, 6, 7 years ago, we are selling at less than that price today. So I was wondering whether I should talk about marigold so that people think it's a golden opportunity. Everybody wants to come into India. Probably I thought this is going to be suicide for me talking, but I thought let me present the actual values and see how it goes. That's about it.
Thank you very much, Mr. Praveen, for this very enlightening presentation. I'd like to open the floor for some questions, please. Yes, Anthony.
This is Anthony J. from Clover Seeds, Hong Kong. You have mentioned the African marigold, but what types of varieties does India prefer? The tall growing type or the real bedding type that is bred by most companies in America?
No, it's a tall type. The bedding types are not preferred. India prefers the tall type that will produce flowers over a long period of time, and that is resistant to breaking during the rains. So those are the preferred types, not the small one which comes to profuse flowering once at at once for the garden.
Thank you.
Mm-hmm.
Thank you. Another question?
Hello, Praveenji. My question is, marigold is a huge market in India. OPVs are also popular. They are grown by some farmers. So is there any study about the bifurcation in the market from OPVs and hybrids? How much OPVs and how much hybrids?
The OPV, open pollinated varieties, what you are talking about was huge. It was a misnomer for the xanthophyll marigolds, which was available at a low price. So people think it is an open pollinated variety, but it's actually a low priced hybrid marigold. So, but other than that, open pollinated varieties, what is you're talking about is probably what is sold around in Maharashtra for garlands, around temples, the open pollinated French marigolds. That market is really not huge.
No, but like Pusa Narangi, if you talk about Pusa Narangi, that is almost similar to this, but small in size.
Mm-hmm.
Many people sow that in areas nearby Delhi and Punjab.
Mm-hmm.
So is there any study made by you, like how much?
I have no idea about that.
Okay.
I have no idea about that. Sorry.
Thank you.
Thank you for your question. Any more questions to Mr. Praveen? Yes, please pass on the microphone. And please introduce yourself.
Anothai Chumsai, Greenville Genetics, Thailand. May I know about your F1 hybrid seed industry in India? If you say yes, please clarify it. Where? If not started yet, you're planning to do research work for male sterile and for hybrid production.
Let me get your question right. Are you asking if there are companies which are involved in F1 hybrid research of Marigold? And if yes, if they are male sterile? The answer to your first question is yes. There are companies involved in research of marigolds in India. And yes, it's all male sterile. It has to be male sterile. And the companies involved in research, one would be my company, INB is involved in research of marigold. Namdari is involved in research of marigold. Then Syngenta has started they have started marigold again. Earlier they had dropped marigold in India. They're thinking of doing, Pan American started breeding in Thailand, and I'm sure that they're going to be trialing in India. So a lot of companies are now involved in marigold breeding. So that's why I kept saying the number of suppliers and the number of breeders are just mushrooming. And the price trend, like I showed you, it has gone from $4,500 about 7 or 8 years ago to now $2,500 is the purchase price of most of the companies in India. I have a feeling that in about 4 or 5 years' time, the marigold price will drop down to around $1,700 to $1,800 a kilo for import into India. The marigold price of production price is anywhere between, say, $500 or depending on, I'm not talking about some of Mr. Yu's marigold which are available at $300, but some of the other African marigolds, you can produce it between $500 to $750. And when so many suppliers are producing at $500 to $750, it will probably stabilize at around $1,750 in the future.
Thank you. So one last question. If none, then we can say. Oh, sorry, I didn't see that one. Last question.
Since it's the last, actually I have a very non-professional questions. I'm from China. I'm a seed company. We produce hybrid rice seeds. I think as an expert of these ornament flowers, I want to know whether there's a variety can combine the vegetable ornament function and eating function. Because Chinese eat a lot of the flowers like a rose.
Yeah.
So any company are developing such a kind of variety that can both be used as vegetables and ornament.
I think that's what I was saying. I was hoping Dr. Yang would say flowers are going to be consumed. If that was the case, we would all be very, all of us would be standing up and saying we'll breed marigolds. But as far as I know, marigold flowers are used for extraction of lutein, which goes to the poultry industry predominantly. So, direct consumption, I'm not aware of.
Okay, so I think that closes all the questions, and thank you very much, Mr. Praveen, for this very good presentation. So we're going to pursue with the program, but I have breaking news for you, because when I announced earlier that one of the speakers was actually dropping out because he couldn't be here, a lady scientist in the room actually volunteered to make a on-the-spot presentation. She happened to have something on her computer talking about CRISPR-Cas, and she's a scientist from Key Gene. So we will be lining her up, but not right now, because we would like to give the opportunity of Szabolcs Ruthner, who is the executive person of regulatory affairs of ISF, to give a quick update on what's happening in the vegetable group in ISF. So Szabolcs, please, you have the floor.
Thank you very much, and thank you very much, Michel and Jack, that give us the opportunity to brief you about some recent issues at ISF. I try to be brief. I'm not here to promoting ISF. I'm here just to share with some information which I think it's important for this region. The first one, it's disease-resistant terminology. So, as you know, disease resistance is a major goal for breeding companies today, and it's a major goal for produce better enhanced varieties, but also it's a tool for differentiating new varieties from the old ones for variety registration and PBR purposes. but also as objective and importance, the terminology, the right terminology of these new disease resistance varieties. And it's important to globally have a system when this kind of disease resistance varieties are described in a consistent way and is globally harmonized. So it's one hand, it's necessary for the farmers, and the growers, and the customers to really be in the same page and avoid confusion when a new resistance variety on the market. So if two companies are working on the same resistance and they distribute it, they market it, it's important that the grower understand that what's the kind of resistance behind those new varieties. And also it's important for the seed companies to have a harmonized system to avoid claims and product liability problems. So that's why at ISF we created a working group. This is, I would say, one of the oldest working group at ISF level. And obviously the work of this working group is one hand to have a agreed terminology on the reaction of plant to different various pests. You know about the terminology about immunity, resistance, susceptibility, high and intermediate resistance, new strains, how they evolve. So we have a common understanding. ISF started this common understanding of position paper in, I would say, in early 2000, and we are updating this paper each year. And I guess it gives you a very good look how to use this kind of terminologies in your daily work. I would say I'm happy because the first time we will issue some translation of this position paper in Asian languages. So in the coming weeks, this will be available in Korean, Japanese, and Chinese, and hopefully other languages to come. So probably this will bring you closer this position as ISF to you in the future. This working group also works on the codes, the nomenclature of these different resistances, different pest-host combination. Every new resistance, if a company claims a resistance, it's coded, so it's usually a 2 or 3 letter codes. I'm pretty sure that most of you seen catalogs of seed companies, and I would say 80–90% of the seed companies are using these codes when they're referring certain resistance. And also it's a kind of new activities. Then this working group started describing new strains and races. The unique harmonized way of naming those strains and races are equally important. Not to mention those cases when different areas and different regions start naming the same races differently. It also can cause huge confusion on the market. So this working group is working to harmonize the unique way or the harmonized way of naming of new races and strains. This is just a table which shows you that how it's we keep track of the different resistance and the different codes. Is available on the ISF website. So what I brought you here because I would like to promote to join to this working group. So this working group is a very dynamic, it's a steering group. So it's not really invent new thing. The main issue and the main existence of this working group to harmonize the existing efforts of public research, efforts of company. So it's a mixed group of public institutes and private companies with the knowledge of breeding, commercial and regulatory backgrounds, and of course great knowledge of disease resistance terminology. We have many members from Europe and also from America, North America, but obviously Asia is one of the most important region for vegetable breeding and cells and commercialization and also production. So it would be very important that in one hand we got all the inputs necessary from the Asian region, and also it would be important if all Asian companies would use this terminology and would use this coding system in the same way as it's been done in Europe and in North America. So I really encourage you to join this group. Most of the information are available at our website. It's www.vertseed.org. So if you have any question, I'm here during the whole week. So please contact me. The other issue I would like to mention, ISF issued last year a guidance document, a guideline about maintaining plant genetic integrity of conventional vegetables. You may ask why it is relevant, why I try to promote this guide to you. I'm pretty sure that everybody heard about the GM petunia case. This case was popped up during the summer. By accident, somebody found out that there were GM petunias on the market. Nobody really knew how it was incorporated and when it was incorporated in different breeding program. What was sure that these events were found in Europe, North America, Japan. These are the places I know. It led to product recall all over the world. So existing seed stock had to be destroyed and withdrawn from the market. So I think it's pretty much readdressed and raised the awareness again that companies need to check or what they, when they access new germplasm in a breeding program or they do various activities in terms of the seed production steps, they need to check more carefully what they are accessing. They need to assess the potential factors that may contribute to AP-related incidents. So we haven't anticipated this when we drafted this guidance document in exactly 1 year ago, but right now I would say it's relevant, it's actual, that we readdress this kind of guidance document. So it's a pretty practical document. It's a QM document, a quality management document, which gives you tips and hints how to address the situation, address this question for the full life cycle of the vegetable breeding and seed production, but also commercialization and post-commercialization. In one hand, it assesses the potential factors that may lead to AP incidents, starting from whether it's an open pollinated crop or a hybrid, it's in an open field or in a greenhouse, what's the biology behind it, is wind pollinated or bee pollinated. So it's really practical in terms of what the risk factors and what could be the potential measures you can do throughout your breeding and seed production program. And also it addresses that what could be done if something incident happens. So what are the measures when can mitigate the impact that such accident or unfortunate incident happens. This guide works together the ISF GM vegetable database. Is a comprehensive database of all publicly known GM releases in the past, I would say 20 years. It's commercial, non-commercial research. We are speaking about vegetables, so it's mainly about research purpose releases, but also it contains not just the vegetable species, but all other species when cross-pollination could be a problem. So for instance, it contains maize because we are producing sweet maize for the vegetable market. And this is available for our members. So what I brought here, this message, this guidance document, that this is provided by the leading QM experts of the seed industry, because we felt that it was GM petunia in this case. So, but you can imagine if it had been a vegetable crop, the consequences would have been much bigger. So this is a kind of common shared responsibility for all of us, because if it happens with one company, it's not only the consequences not fall back on this company, but the whole entire industry need to cope with that in the future. So I really would like to encourage you, if your company doesn't have this kind of quality management system in place, please visit our website at again this is the address. And again, I would like to thank you your kind help that I could say this message here in this forum. Thank you very much.
Any question? I think my microphone is not working. Any question from the room? Yes, bring the microphone.
I think the International City Federation consider about the nomenclature of some disease. It's very good, proper time to think about that. I really agree about all of them, but one thing is that when we have discussed at the International Crop Root Working Group, there are some kind of some pathogen, but also others name. But important thing is the name of the gene, resistance gene. Name also should be reorganized and should be considered. But in your mentioned topics, I think that you didn't mention about some specific resistance gene nomenclatures. So please, can you some consider about that at ISF working group?
Yeah, it's deliberate. We don't register the genes itself behind the resistance. We only register the phenotypic answer. So that's why we have well-characterized set of differential hosts. And using this kind of differential host, we can test if each strain and races that which was characterized earlier. So we don't examine the genetics behind it. We just examine the phenotypic answer, and we decide on that with the differential sets we use for this kind of purpose.
Okay, thank you. Any other question before we? So if not, Szabolcs, thank you very much. Now we're still on time, and would like to thank again Shital Dixit, who is the lady scientist who actually volunteered to make a quick presentation. Well, quick, and I think affordable presentation on CRISPR-Cas. But before that, Jack is going to introduce briefly Shital.
So
thank you.
We did our homework very quickly on our surprise guest. So Dr. Shital Dixit is the Business Development Manager Asia for Keygene. Keygene is a crop innovation company based in the Netherlands. She has a doctorate in plant molecular genetics from Wageningen University in Holland. She took up a career in business to translate application of science to the benefit of companies and farmers. As you might know, Keygene is active in providing biotechnological solutions to seed companies. They've done that for about 30 years now with quite an impressive track record. Let me welcome Dr. Dixit.
Good evening. First of all, thank you very much for the chairs of the session to be very spontaneous along with me. And thank you for not putting the burden on me as being a scientist. Yes, by training, I am a scientist, so a little disclaimer here. By no means I'm an expert in CRISPR-Cas. However, we as Keygene, which is a crop innovation company based in the Netherlands, we do take technology that is required for crop improvement in a complete integrity with how it is applicable in each region. And therefore, today I'll attempt, looking at the audience, to present the technology in the light of how it could be applied for crop improvement, but also how it can't be seen in isolation with the regulatory landscape that exists in our region. So I hope I do justice with the trust you put in.
I think you might have to just use the arrows on the, not the arrows, so back.
Oh.
Yeah, these ones. Right and left. Yeah.
All right. Yeah. So basically, what I want to show here in this slide is that gene editing technology per se is not new. It has been there for past 20 years now. The only difference now we are all talking about CRISPR-Cas is the way the gene editing technology has evolved. And today we are talking CRISPR-Cas because CRISPR-Cas has become democratized, if I may. By that I mean that today every lab can attempt to use it on its own. It can design the structure and can use it on its own, even a lab which is not sophisticated. And that's the reason why it is so hot, as you call it. So basically we don't have a cursor, right? What you see from the top to the down is we're familiar with gene editing technologies like meganucleases, zinc finger talons. And what I've shown there on the left, on your right is how these technologies have become very easy in the way you could design them and increase the chances of success. And that's where CRISPR-Cas lies. So here, basically, when we talk about genome editing, it is nothing but making a double-strand break in the DNA. And how this break gets repaired determines the outcome. And based on the outcome, one can determine the application in how they can use in crop improvement. So I'll quickly walk through the application as we see this and apply it in crop improvement trajectories. Here, one of the very well-known and popular method of gene editing is gene disruption. Basically, you make one double-strand break and you let the repair mechanism repair it, and there you can introduce either a deletion in a gene or the open reading frame of the gene or completely loss of function of a gene. So this is a very powerful technique which is used also quite widely. Then you can think about large deletions. So basically what you can do is you can insert 2 breaks in the DNA and delete the entire region in between. This region can cause disruptions or loss of function of a gene or multiple genes or even a locus. So this can have a very beneficial effect, especially when in breeding, when you want to have a region which is undesirable out in from your elite lines. But also, you could use it for inversions. So sometimes there are lines that are difficult to breed or to cross. But if you can in a very targeted fashion, select the region, you can inverse it, and you can make the region either functional, or you can actually even disrupt the region or conserve the region in your elite lines. So this is a very powerful technique in breeding. With this, it also can help breeder to maintain the homologous lines. There's another methodology which you could use with gene editing is the somatic recombination. There are certain lines in crops which are very difficult to have a meiotic recombinations. And there are hardly any techniques available where these regions are so conserved that they often don't get crossed. This either could be beneficial where you have a conserved region and you want them to be in your hybrids, or this could be the region which are having a linkage drag and have a deleterious effect and you want to get rid of. So imagine if you have that challenge. Now you can introduce double-strand break exactly at the same position and 2 locus on their chromosomes and can actually introduce the stretch of DNA either you want to preserve or you want to have a recombination with. The applications can be huge. You can actually have a hybrid made instantaneously with the desirable region introduced in your elite lines. Then this is a very powerful technique which is called a localized frame shift. Basically these are, you make exactly 2 double strands break in your DNA and you let the repair mechanism repair it. And sometimes in this repair mechanism there's this one base pair which is shifted, just one. And then the whole open reading frame or the locus gets disrupted. And this can be also a very useful application where you only want a very specific a small region in your gene to be dysfunctional. And this is called the Key-Base Excel. It is actually a microsurgery. This is a flagship technology of KeyGene I'll talk to you about in a second. This is a very targeted way of gene editing. Basically what you're doing here is actually you're introducing a template which is homologous to your target region, but with just one single base where you want the which carries the mutation you want to have in your target. And this is how you introduce a very targeted way and mutation in your desirable region. And and then last but not the least, is called the large insertions. Basically, this is the landing platform for any large insertion. Obviously, this will be a GM, a way where you're inserting a DNA. But imagine now companies, for instance, the Roundup BT insertion can be inserted in a very precise position rather than randomly into the genome. So also, these technologies can help the existing way of gene functioning into the crops. So I just gave a very quick overview of how the gene editing can be useful in crop improvement trajectories. Now, delivery of gene editing tools can be done in different ways. I have put now the one and the most popular one that is used, which is the transgenic way, where you actually introduce the plasmid DNA and you have a vector, a carrier that takes your CRISPR-Cas9 into the genome, and basically you have your transgenic plant and you can cross that event out in the next generation. Like you can cross the Cas9 out and your final product is actually Cas9 free. So you have a non-GM product. Well, basically only in US it is declared as a non-GM line. That's why I put a question how it will be seen in the rest of the world. However, it has its disadvantages as well. Since it's a transgenic active component present in your transgenic line, the Cas9 protein, however, it has a very specific functionality, it remains active. And so there are chances of off-targets that can happen. And the other disadvantage is it can't be applicable to crops which are vegetatively propagated. So then we are talking about transient expression. This is more desirable because basically what you're doing is you're only using the plasmid DNA, but then you're introducing straight away into the protoplast. So you're not, it doesn't get incorporated into the genome of the plant, but into the protoplast. And this is where the Cas9 protein activity remains for a very short time, like 1 or 2 days. So the chances of off-targets are very limited. And this is a technique, we call it short and sweet, is actually more desirable in Europe. And we have thought as KeyGene even a step furthermore, where we don't require, it's called a DNA-free technique, where we don't require plasmid to deliver this Cas9 protein. Basically, we can synthesize this both Cas9 and the guide RNA into this tube and deliver the whole integrated product directly into the protoplast. And this is how we think this could be regulated differently. This is a flagship technology of KeyGene, which is called Key-Base Excel. And basically here what we are doing is we are extracting the protoplast from the plant that you want to have mutations in. And we synthesize an oligonucleotide which has a homology to the target sequence that you want to have a mutation in, except for that one base that you see here in blue. That is one base which is carrying the mutation, and you want the mismatch, and it's delivered together with the molecular scissors, and then you expect that the mismatch repair mechanism will actually incorporate this mutation into the genome. The frequency of this mutation frequency of this technology also has improved a lot. And basically, this is where we are targeting to enable this technology to go non-GM. We have used gene editing in multiple crops, heavily into vegetables, but also into field crops. And we have done various applications for crop improvement, namely under these titles, for plant architecture, for reproduction, for example, to develop dihaploids, and for disease resistances. We worked a lot on having mildew resistances in vegetables, and for epigenetic regulations, and for fruit ripening, for example, having longer shelf life in plants. So we've got also proof of principles and some success stories, and as you can see, it's a mix of vegetables and also field crops, where we have used a visible target, a selectable target, which is a herbicide, where we were successfully able to mutate to the herbicide tolerant gene and make these plants herbicide tolerant. So here what I am presenting in this slide is my attempt here is to show how all the technologies that are developed are seen from their non-GMness in a scale from being very non-GM. For instance, the marker-assisted breeding is clearly a non-GM towards CRISPR-Cas and transgenesis as in GMO-regulated technology. This is the scenario we know of as it is regulated in the US. Basically, what you see there in the red line is where the US has drawn the line, where they say that the CRISPR-targeted cisgenesis, genesis, CRISPR-targeted transgenesis, where the foreign DNA is inserted, or the transgenesis are certainly regulated under GM. And the oligo-directed mutagenesis and the null segregants. Null segregants are those events where you do use a transgenic approach, but you can cross the event out and your final product is free of that. That's a null segregant, which is also falling outside the GM regulation. And CRISPR mutagenesis as well. Now this is where EU stands. EU actually has two lines drawn. It is very clear about what is not regulated, the marker-assisted breeding and random mutagenesis events that can occur in nature, and also CRISPR-targeted transgenesis and transgenesis as GM. However, everything in between, as you see, is still under discussion. And a discussion in the sense that whether they should fall under GM or non-GM based on, and the argument is on naturally occurring events, no insertions of foreign DNA. So the discussion can swing either way for some of the technologies. However, if you see that there are lots of technologies that are undecided in the EU, we as KGene have taken a position where we are lobbying quite actively to influence, or let's say put our case to deregulate or regulate differently some of the technologies that lies in this middle section. And that is the following. But before that, let me give you a little landscape of how the EU is looking today towards the acceptance of gene editing in the light of accepting, as you see, more positive sentiments in green and in negative. You see that mostly it is all quite positive, except for countries like Netherlands, Germany, France. They remained undecided. They're still thinking about it. However, they are not negative. There are only two tiny countries that have negative sentiments about this, and I think they are the Luxembourg and the Austrians, but they are also non-agriculture countries. So this is good to have an overview to see how this discussion is progressing in EU. Like I said, we as KGene are of this opinion that at least the oligo-directed mutagenesis and the CRISPR-Cas mutagenesis should be kept out of the GM regulation, and the rest can be further discussed. And our stand is because these technologies have no insertion of foreign DNA and mutagenesis, hence they should be not regulated under the GM. Of course, we talk about these technologies and why we strongly believe in it because there is an added advantage from consumer point of view, but also from growers' point of view and from breeders' point of view. Of course, this technology have environmentally, it's a very environmentally friendly technology because it enables us to, for example, use less pesticides. I think there is this whole sentiment going on about, if I'm not wrong, neonicotinoid ban in Europe, and I think a lot of countries have already banned it, and the rest are on its way because of the health hazards of the use of it in general. And imagine if we can overcome that with very precise technologies that can enable us to do so, it's only great and more sustainable. Of course, it gives us more choice of flavors, shapes and colors in our vegetables and fruits. But also, we talked about fortifications, and I think this is a very important technology that will enable us to walk that way in our plant-based fortification. And for growers, of course, adaptation to climate change, harvest security, higher yields to feed a growing population. I think nobody can agree more than this. But there's also this new trend coming up on new city farmings, which require very specific crop to be developed in a very short span of time, and we think this technology can contribute significantly in doing so. For breeders, I think shorter breeding time is everybody agrees to is needed, and I showed you by some of the examples how we can overcome that using this technology. Of course, benefits of these technologies are needed for food production, but why are we talking it now? Because we know that we are moving with such a pace that also our technology needs to deliver the solution in the pace that we are talking about. And I think this is a technology that can enable that demand for faster solutions, and of course acceptable to the society. And this can be achieved, of course, with the GM technology we all know of, but it's not always acceptable to the society. And of course, classical breeding can go on, but we also know it doesn't match the pace we are looking for. Can't wait for 1,000 years for that improvement to come. And so gene editing, I believe, is the holy grail, as we call it, of today, because it can give that impact that we are looking for to deliver clean, precise, fast, and safe technology. With that, I'll thank you for your attention, and I'm happy to take questions.
Well, thank you very much, Shital, for this outstanding presentation. So we can invite some questions from the floor, if there is any.
I think everybody is in agreement that this is it.
Yes, and still a complicated subject to deal with. But one question, yes, Mr. Praveen.
Can you tell us about the costs estimated with using this technology for, say, a crop like tomato?
The cost estimated to?
Come up with a new edited product.
Right. So the short answer is I cannot, because really it depends on what you are targeting this technology for. So I can give you the circular application slide really shows how you can capture the value of this technology from if you say from seed to the product or time to the market. I think that will depend on what you're looking for. For instance, if you're if you're looking for a technology where you want to create hybrid infused steps with those challenges with somatic recombination, for instance, I'm just taking an example out loud, then you can imagine that first of all you're making something which was impossible possible. That is one. Second of all, you can make in 3 generations a hybrid. I think that is a very big gain, and from then onwards you can actually fix your hybrids, because these regions you can fix as well, and then you're ready to go to the market. So basically, if I have to do the spontaneous calculation, it is going to be the valuation in the time that you gain, and in the new product that you can now develop.
Thank you.
And of course, to add to that, depending on how that application is going to be regulated, if it falls under GM, then the whole cost calculation is going to another different level. But if it gets regulated differently, then it will definitely have huge advantages on costs.
Yes, another question? Kindly introduce yourself.
I'm James from Indo-American Hybrid Seeds, India. I just wanted to know, like since there's a lot of climate change happening across and a lot of challenges the agriculture and the business is into, and if you have applied gene editing in any of the countries where you have seen a great success, can you please say some few examples or few illustrations where you have done that and it's been a great success? Thank you.
Right, so here in these 2 slides I presented some of the success stories. This slide basically represents success stories using the gene editing technologies in general, and that could be anything with meganucleases or with talons. And this is very specifically using the microsurgery, the key base technology, where we have shown success stories by developing herbicide-tolerant crops in vegetables and in field crops. So it is workable, you can commercialize it, and there are already varieties out there.
Okay, thank you. Any other question? Last question, maybe? No more? So thank you very much, Shital, for this very good presentation. Thank you. So now we have 2 more points to cover to finish our session. So one is the usual invitation for active participation in this group. As you can see, this group is very active. There's many things going on. We are working hard to bring you interesting subjects. We're trying to discuss interesting topics among ourselves, but we still require some more active participation from the audience. So this is a call I make, and we make now every year at this event. If you think you can contribute something to this group, you're an Asian company, please come forward, contact the Secretariat, Jack or myself, and we'd be happy to accommodate you in our discussion. So six times per year we are meeting virtually or physically, and this is the time that you can basically bring your contribution to the group. So please, anyone, I will not ask to people to raise their hands here, but I expect maybe some mails coming to us and some active participation. The next thing I would like to say is basically all companies present here should basically update their information on the Apsa website. It has already been informed that this website has been updated. It is more user-friendly, but you can update your own information there, and provided how you are updating the information, whether you are a breeding company, a producing company, then we would be able to target more those companies, and by sending them the correct message or inviting them to some particular meetings. So please go back to your registration and to your member information, so that we can target you better. And this is also how I mentioned we were targeting integrated seed companies. Well, unfortunately, a lot of the companies whom we know are integrated, are doing breeding, did not have the information updated on the website. So please do this, and then we will be able to target you in our future activities. Talking about our future activities, and this is our last point of the day. So some of the things are cooking in the SIG Veg and Ornamental Kitchen for next year's and the future years. It is the study tour program is usually a very good program that members do like. So we are planning to continue to organize study tours. Some of the countries we are targeting in future, and the closest future, is maybe a study tour in China or Japan or Italy. Depends on who can help us organize these ones. If anyone else has some other suggestion, please do so. But we will first, let's say, target of maybe organizing in the summer of next year a study tour to China. The challenge will be, of course, to try to find a good area in China that could be representative of a trip like this. So that's one. The other things, of course, is that we're putting big hopes on this working group of integrated seed company that we will launch tomorrow. And then, of course, it's a more select group of companies, but we hope to generate a lot of new ideas, new activities, and new discussions that we can generate there. So this working group is open to, well, Asian companies, and we hope to have more Asian representatives of these companies attending this group and participating in the discussion we have. So I think we have covered most of the items, and I think what we're left to do now is to thank our speakers and give some memorabilia for our guest speakers. And I'm not sure we will have something for Shital, because I think the name is engraved in there, but we will definitely show our appreciation in a certain way. So no names engraved. So you will have your memorabilia. So it's okay.
Thank you, Chair and the Co-Chair. And this has always been, normally we used to start with vegetable session at all our Asian Seed Congresses. But then this time, since it was in Thailand, we thought that let us first discuss the opportunities in the seed sector in Thailand. And that's why we had the trade and marketing session shifted here in the first. And this session always has a house full, and I was very happy that we had to ask the hotel to arrange some more chairs when the hall started filling in. That shows the interest which our members are taking in this particular session, particular group's activities. And as Michel had said, see, I have been managing 7 groups, and this is the group which gives me most of the late nights working on this, because we try to do a lot of member servicing through this group, because we realize that most of our members are interested in the vegetable seed business. Now, I'd like to thank our chair, Michel Devarrewaere, with a small gift, as he said.
Shall we not do the guests first?
First to you. Okay. Now may I request Mr. Jack Metzelaar, our co-chair. You would have noticed that Jack has been with this committee for a very, very long time. He earlier was a chair of this particular committee, and he continues to this. So a big continuity which he has been providing, that is really appreciable. Thank you. Now I'd like to request the chair of the committee, Michel, to give away the souvenirs to the speakers today. Thank you.
With no names engraved. So, so Dr. Young, please. So, Mr. Praveen. And finally, Shital Dixit. Thank you very much. Sorry? Szabolcs has also one? Oh, okay. Yeah. Yeah, Shital first, ladies first. That's how we do it in my country. And Szabolcs, you also have the right to a memorabilia from Apsa, so. So thank you very much, and with this I will close this session of the special interest group of vegetables and ornamentals, and I'll say see you next year. Thank you very much.